We're trying to expand the toolbox that farmers and other ag practitioners are able to use, adjusting practices for the landscape and not adjusting the landscape for the practice. This has to be a problem, especially for ag practitioners and farmers. It's good for anybody to have a plan for a rainy day.
Welcome back to the Water Table. Today we have Christy Gibson, a distinguished postdoc scholar at University of Illinois, joining us today remotely. Christy, thanks for coming on.
Thank you for having me. Very excited.
First question I got for you, what does it mean to be a distinguished postdoc?
So Illinois and other universities, they tend to identify researchers who they think have the potential to be tenure track faculty or research leaders. And so different departments on the Illinois system campuses can nominate some of these candidates that they've identified. And then they're approved through a university process. And then once you're approved, then you start kind of like a faculty fellow program where you get trained on how to be or get prepared for a tenure track faculty position.
Oh, I was really hoping that you were going to say something like, I just really feel like I'm pretty distinguished, so I wrote that on my business card.
I mean, that is something I would do on the weekend, but officially, it turns out I am distinguished. So
Perfect. Yep, you got that in writing. That's awesome.
yeah.
We came across an article in Drainage Contractor that some of your work was mentioned in, and that's kind of how we got your name and got in touch that way. And the title of the article was digging into tile drainage and research a little bit, but the title of your paper is, at least the title of it, I think there's more after it, keeping pace with intensifying ag field inundation events. And that's a lot of the work that you've been doing here within your work at University of Illinois. We want to dive into some of that stuff. But first off, can you give us a little bit of background? You have kind of a unique background within agriculture and how you got into water and some of the research that you're doing at Illinois. So want to walk us through a little bit of where you came from and how you got here?
Oh, yeah, sure. So I'm originally from Nassau, Bahamas, so I'm no stranger to water, being from a small island nation, but also not a stranger to severe weather and extreme inundation events, because we are in the hurricane zone. And so we've gotten quite a few very severe hurricanes. And so severe weather has always been sort of like a part of my life. And then I went to Tennessee State University to get an undergraduate degree in chemistry with biology because I thought I was going to med school like everybody else. And it's like kind of like the severe weather followed me wherever I went. I don't know if I'm bringing the severe weather or if I'm just attracted to it. But I was actually in Tennessee for those record like 25-year and 100-year floods, and then the tornado outbreak in April 2010 and the one in 2011. And so severe weather has kind of like been following me. And then I went to the Midwest. So I was like, great, I won't have to worry about any of this. I went to Purdue to get my PhD. And I kind of ended up there because when I decided I didn't want to go to medical school anymore, that it just like wasn't for me, I did a master's degree in plant and soil science in agriculture at Tennessee State. And so I started off kind of on the biotech side, but it was still dealing with like this extreme weather. So I was looking at heat stress in heirloom potatoes that had been bred to resist or like to have resilience to this heat stress, and how these things interact with soft rot pathogen, which is a huge problem for potatoes. If you ever go to the store, you get a bag of potatoes and everything looks good, but you pull one out and it's very soft. That is soft rot. And so that's kind of like what I was investigating. And then when I was thinking about grad school and getting a PhD, I was just like, what am I going to do? I have this varied background. I like constantly working with instruments, mass spectrometers, all this stuff. Like, what do I do? And then I heard about this project with my PhD advisor, and it was looking at black carbon deposition in northern temperate forests. And so I was just like, oh, this is great. And it was dealing with more severe weather because I was looking at fire. So it was like kind of a trend as I traveled along. And while I was at Purdue, I figured like, I would have to go towards the fire in Michigan. Um, but then severe things started happening at Purdue. There was like an ice storm. The entire town was like an ice block. And I was just like, what is this? Polar vortex. And I was just like, I'm just getting all of this. It's like I can't escape the severe weather. But while doing my PhD and working with black carbon, which is also biochar, a lot of the background sort of information on black carbon that I was working with biochar actually came from agricultural systems. And so um, that's when I kind of like really kind of started to transition into ag systems because even though I was working in temperate forests, colleagues and other lab mates, they were working in agriculture. And, if you get a PhD or a master's, you often collaborate um, with your peers. And so I always had like this sort of ag background that kept popping up. And so then I found my first postdoc position at the University of Illinois Urbana-Champaign, and it was going to monitor emissions and nutrient cycling in bioenergy crops. And it turns out that there's more severe weather because then I got to Champaign and I started experiencing all the severe weather I had all my life, from hurricanes to fire to tornadoes and more polar vortexes. And but while doing my first postdoc, I started to notice something. Everybody was studying drought. They're like, oh, it's so dry. And then one summer, we had these crazy storms. I think it was like 2020, and the field inundated, and this like 2-ton piece of instrumentation almost floated away. And I was just like, does this like happen all the time? They're like, yeah, this plot's always flooded. And then traveling between the Midwestern states, I started to notice like, hey, isn't this place tile drain? Why is there standing water on these like flat fields? What is happening? Um, and everyone's just like, it's just the Midwest. I was like, but no, this has to be a problem, especially for ag practitioners and farmers. Like, how do you even get in here to do anything if your field is flooded? Like, do you plant around this? And so I started to get interested in how field inundation might be impacting agroecosystems. So, like, I know there's some tangents in there. They're in there for entertainment value. But that's basically how I got here, is like just looking around and making this observation and getting kind of like fired up because I felt like it was something that was being ignored, especially from a research standpoint.
Yeah, and a lot of diverse, I guess, weather patterns that you've been experiencing through this whole time, like you mentioned. But when we are talking about inundation, big fancy term for flooding.
Yes, it is flooding or it's ponding, waterlogged, anytime there's standing water on a field, so it's inundated.
Yep, and we see that all over the Midwest with a lot of ag fields, especially this time of year. We're recording this here in early June, and a lot of people just got in there planted. Hopefully, again, like they got their whole crop or all their field planted. But like I said, there's going to be some times where you have to go around it, go around those wet spots. And that identifies your need for tile in some of those spots. Or if you already have it, maybe more intensely drain in some of those areas. Or like a lot of people have done in different parts of the country too that I've seen, is they just farm around it, and maybe you'll get back in there, or maybe plant it, but then it drowns out. Then you'll have to go back in there again later on too, or deal with weeds, whatever that may be. So like I said, it is a problem with just looking at it from an agricultural standpoint, and an efficiency of not having to go back 2 or 3 times, or having to go back 2 or 3 times, that inefficiencies that come with that. But I'm sure that's something that you've really dove into, especially working on your most recent paper. Is that right?
Yes, we looked at some of the things farmers do to mitigate that, to combat this. And one of the big things is just like replanting. Um, that's, how many times in a season do you have to replant? And some of the solutions that we've been talking about that might work is, planting different crops in those poor drainage zones. And so a lot of work is being done at UIUC to look at perennial grasses for this purpose, miscanthus and switchgrass. However, like the issue with this is like, how do we make this or convert this to a cash crop? And so, what is the incentive for planting perennials? What is the market for it? Can we create new products, not just bioenergy, so that, farmers get the most out of these practices? And then folks are doing cover cropping. There is some conservation till, but, I think about like, what are some other things, larger scale infrastructure that could be incorporated that'll help with this. And so, you know, subsurface drainage, you were talking about it, like, maybe updating your tile, but we don't have like enough on controlled drainage right now. And so we need to partner with companies and with engineers that are looking or developing these controlled drainage systems that'll, kind of help farmers manage water better. Um, you know, the water may not penetrate the soil when your tile drains aren't working. So it's just sitting there. So like, but that could be a whole lot of water that you could use later. So if you implement controlled drainage, then you might be able to save water for later. Store it and for when you need it, when you need to irrigate. Because then my favorite topic that I like and is an adversary of mine, drought, comes in, and so there's the need to irrigate.
Yeah, exactly. And that's something that within our industry, we've been looking at a lot of those different practices that are out there. So I guess the way that I kind of think about it is, more or less a tiered approach where you have, conventional tile drainage, that's removing water or letting that water get through the soil profile and then removing that off. Then kind of that next step is controlled drainage where you have some stop logs or you'll be able to stair step that water table throughout your field, manipulate that water table a little bit throughout the season. Like you said, if there is drought circumstances that are coming up, or look at the 10-day forecast, it's going to be hot and dry. Can put in different control mechanisms to hang on to more of that water, preserve some of that moisture. Then kind of that next step is getting into sub-irrigation or subsurface irrigation, where you're kind of applying that water, directly through your tile system, kind of like a dual purpose system there too. And then kind of the last one that I, again, think of it in this tiered approach is with drainage water recycling. For those times, like you just mentioned, is you usually have too much water in the spring, not enough throughout the late summer. We can capture some of that water, the excess water in the spring and apply it throughout the year there too, to always make sure you have the right water needs. And those are some technologies that are still being kind of developed and proven out a little bit more from a true science and data standpoint, but then also looking at a lot of the economics of it. Where again, a lot of these practices are cool, they make really good sense, but getting the dollars and cents to work out for implementation on that side too, to really bring down that risk of the water issues, mostly on a quantity side for either too much or too little. And then the other part of it too is with, from the nutrient standpoint as well, is essentially the more water that you're holding back, the more, nutrients and phosphorus and nitrogen get to be used up within that soil profile too by something living. So those are all, again, tools that are in the toolbox, just on the water side. But then kind of like you mentioned as well, is there's all these other different pieces of the puzzle for your tillage operations, your different crops that you're planting. The whole ag system kind of works together to, look at these issues a little bit better and dive into them. So, and that's from my understanding kind of what you're looking at with some of your research is, how do all these pieces fit together to get the best solutions?
Yes, that's exactly what we're doing. We're trying to expand the toolbox that farmers and other ag practitioners are able to use. Um, because not all fields aren't created equal. Within one field, there's tons of heterogeneity. So there's such a variety. It's so diverse across the landscape. So comparing farmer A to farmer B's plots, they're going to be entirely different. And so they may not require the same solutions. But what if we, what if we vet as many practices, technologies as possible so that they could kind of like choose what their specific toolbox is for their landscape. And so I think it's kind of like adjusting practices for the landscape and not adjusting the landscape for the practice, which is what we've been doing. And right now with like the intense precipitation and rain events and all of the flooding you get, like that's not something you could really control at the landscape level. And so you don't necessarily need to adapt the landscape. You could, well, sorry, you could kind of like work with the landscape rather than, trying to work like against it or change it too much.
Hmm. Yeah, exactly. And there's different aspects there too. Like I said, from the practices that you're looking at on the field, and you mentioned a couple of them with perennials or cover crops, a little bit of some tillage aspects there too. What else are you all kind of looking at or setting up for maybe a prescription, say, for some of those landscapes that you're looking at in Illinois?
So getting back to my favorite amendment, biochar, basically how we could use, kind of like these custom amendments that are applied in kind of like as spot treatments, not across an entire field, because, you know, you'd have to be applying a whole lot of biochar or some amendment across a field in order for it to work. But what if you could just apply it to like those trouble spots in order to manage water? And so we're looking at specific amendments. We've also been thinking about like the ag biological space. How do we use microbial communities or other pest management tools. Maybe they have like a dual purpose. And so to get very, very specific here, one thing we talked about is when we look at biologicals and we're introducing like a microbiome to the soil, right? These microbes produce like these extracellular compounds that are kind of sticky. They're like a glue and they help with aggregate formation. So what if in the long term they help build aggregates and those aggregates help drain soil better or help water percolate through the topsoil much better. And so that is like, that's highly detailed, but it's something that's in the pipeline. Like, what are the other benefits of some of these best management practices that may be used for enhancing soil health that may actually be changing like soil structure as well. So we've looked into that and those hope to test biologicals in the future in that way. And then really looking at precision agricultural approaches. Again, I think like you hit on that already with the subsurface drainage tools is like, maybe you have regular tile or you like, maintain tile in most of your field, but like you have this trouble area where you may need to, install subsurface drainage to that one area to kind of like keep the entire field sort of aerated. And so these are the things that we're really looking at. Also perennials, but I think like we're making advances in the perennial space already. And I think like one area in, with perennials, we talk about products, right? So if a farmer is already growing perennials for drainage, what if you could take those perennials and make a custom biochar that you then also apply to the field in the trouble spots? And so then like you kind of create a product that's going right back into the field again. And so there's like this nice circular bioeconomy developing because of that. And so we're just thinking about like, multi-use. in some of the things that we're already, kind of investigating for other things, can they be used for this particular problem?
Yeah, for sure. And that kind of gets into, what we've been working with within Prinsco and some of our within the drainage industry is promoting having essentially a water management plan, whether that's just for your field or, ideally for your whole farm. Like I said, if farmers know where where their problem spots are at, whether that's through yield monitors or just, talking at the coffee shop or thinking through some of that stuff where they know the issue spots. So what can they do to have a plan for addressing some of these? And like we said, there's a lot of tools that are in the toolbox for addressing them with technologies or different practices and whatnot. The one that you mentioned here a few times, and I don't want to get too much off on a tangent on it, but with biochar, I've heard of it. I've heard of it as an amendment. Can you explain that a little bit deeper?
Yeah, of course. So biochar is, if you ever look at, biochar is kind of very similar to the coals that you use for barbecuing. And it's basically an activated carbon. So it has this activated surface and, that means like it attracts things. And so it attracts organic matter. And so it's able to quickly bond to those components in a soil. And so the thought with biochar is since it's good at attracting organic substances, then it's probably going to be fairly good at aggregate formation. However, the issue is that biochar oftentimes comes pulverized, so as a powder or as these pellets. And so the issue then becomes with engineering biochars that stay in the soil once it gets wet. Because if it's lighter or less dense than the soil, then it's just gonna float away. And we kind of don't want that. And so we're trying to come up with ways like thinking about size and like ways to compact the biochar to increase the density of the biochar itself so that like once it's tilled in, it kind of stays there and it's able to like start forming these larger aggregates. And so that's kind of like what we're interested in looking at. Can it be used for this purpose? And so on the flip side, it also is really good because it attracts a lot of organics, is really good at nutrient retention. And so it adheres a lot of compounds that you want to stay in the topsoil. So you don't want to lose your phosphates. You want your nitrates to stay co-located with plant roots. And so biochar definitely has been proven to do that. Like we've seen that in the literature and we've actually seen it in practice as well, that it helps to keep things in the soil and not sort of like moving away with the water, like not being leached out um, into like larger water bodies or, somewhere further down. We'll always talk about eutrophication, those sorts of things. So basically to keep applied fertilizer and herbicide and everything like in the soil, like
Where
that
you want it.
topsoil profile. Basically, you
Yep.
want to keep it where you want it. I don't want it in my neighbor's yard. That's not helping me. I want it with my plants, so that they can use those nutrients. And then another thing is like you also don't want the microbes that are beneficial migrating with the food. You want them to, well, not migrating, you want them to grow like a healthy, population where you have those nutrients with the plant, not elsewhere necessarily. Or you don't want them to like not grow. And so,
Yeah, that's another. complexity under the soil there too, and I'm sure
Yeah, that's
all
going
that
on.
biochemistry is going on there anyway. But another piece to add to it too, especially if you want to enhance some of that stuff. And that was kind of my question, I guess, the last one on biochar. For you said that there's proven out in some of the science literature and plots and things like that, as well as starting to get into practice. Is it that costly that it's not rampantly scaled up, or what is kind of the hurdles that it has to overcome?
Oh, scaling up definitely. And another thing is like I don't think anybody wants to cut down forests for biochar. Maybe they do, but like that wouldn't be ideal, you know? And so ways to source materials locally, maybe yard waste is a good one. But again, like if there's already biomass or there's already plants being grown, at a scale to where you can actually apply it as needed because, biochar is applied on a per carbon basis. And so it's like per gram of carbon in soil. And so for when you think about here in the Midwest, most of us have mollisols and alpha sols, right? And those soils are very organic rich. And so if you have a soil that's anywhere from like, 15 to 25% carbon, then that's a lot of biochar to add. And so is that feasible across an entire field? I highly doubt it. And so we need to find more clever ways to use these amendments. And I think, again, a really good way is spot treatments. Like you apply them exactly where you need it and nowhere else. And, farmers, engineers like yourselves, you're already kind of like using the tools necessary to apply these. And so if you're, geotagging areas of concern, then we know that we could create a perimeter perhaps to apply the biochar. But yeah, definitely upscaling is a problem and making sure we have like an adequate feedstock, something that we're not necessarily importing from elsewhere, and trying to keep this as like local as possible. And I think like one of the promising avenues is again, we're encouraging farmers to plant bioenergy crops. Maybe there's like a waste stream that can be converted to biochar, but then also like we have tons of yard waste every year. The trees are dropping branches. Maybe we could, come up with some really unique chars that maybe are a combination of these different sources that can be applied.
Sure. Well, I never thought I would learn so much about biochar through this podcast, but this is awesome.
Yeah, biochar is interesting. I'm definitely like, I'm a proponent for it, but I'm also like, yeah, we have to be careful how we're making it. And then we have to make sure that like when we encourage its use, it's actually doing
What we want.
what we want it to
Hmm.
do.
For sure. Well, awesome. Thank you very much for the time here. I got one last question. You said you severe weather has followed you all around throughout your whole career, and now you mentioned here before we started recording, but it was dry. Now we got some rain coming in, so finally getting some moisture.
Yes, we are. And actually, I don't know if you could hear it in the background or maybe it's buffering, but I don't know if you heard that big boom. That is
Got
thunder.
some storms rolling in, huh?
We have some storms rolling in, and I'm obviously very sad for ag practitioners, but like sometimes I feel validated by the storms. And so it's supposed to be a very wet 2 weeks here in the Midwestern corridor. And so we're expecting to get maybe some flooding. In fact, we had flooding in Vermilion County just yesterday, when it didn't rain that much here in Champaign County, but Vermilion had some pretty intense rain. And so we'll probably be looking in that area with using remote sensing to see like, if we can tell if there had been any damage to any new crop, like any seedlings or younger crops. And so it's exciting for us, probably not so
Not so much for
exciting
the farmers.
for farmers who have to work in it. But it's exciting because I think that like, the data we're collecting hopefully could go into decision-making tools, that'll assist in these, like you said, these water management plans. Because I think like it's good for anybody to have a plan for a rainy day. You have a rainy day fund. It'll be good to have like a rainy day sort of plan for if you are facing potential flooding event. And so, kind of applying that rainy day sort of approach to actual rain in
Yeah.
ag systems. So,
Yep, that's well said. And better to do it, before it's the rainy day too, to have all that
exactly.
stuff in place.
Exactly. So I'm so happy to hear that you all are like coming together to try to encourage farmers to have a plan. It'll probably save a whole lot of money and a bunch of work days because workday loss is huge as well with these flooding events.
Absolutely. Yeah. And again, that's something that we keep advocating for is have that plan to know what's going on in your field, and again, before the rainy day.
Exactly.
So what's next in your research, or what are you looking for to do in the future?
So right now in the future, we're looking to collect more data because it's hard to predict where a lot of the flooding will be. And so the more places we can collect data from, the better. And so we're kind of like, interested in collaborating and expanding the research across the region. And so really, um, the future is like just like a call to arms to other researchers in agricultural flooding and practitioners so that we can partner with them and get sort of these like real world measurements in real time. So immediately following an inundation event, like what data can we collect? What methods are best to collect this data? And then also what data is most useful? What's going to be the most impactful for practitioners? And so, yeah, that's our next step, expansion.
Yeah. So is there some outreach and stuff that that you are looking for, like you said, kind of specific sites that have some of these ponding areas, and then you're looking at, I assume, soil types and how long was it ponded and the yields and the whole prescription of what the farmer's doing?
Yes, all of that. And then also if they notice, if they have any symptoms or they see any symptoms in the plant of rot, like root rot in seedlings, like that sort of thing, we're totally interested in that. We have a highly interdisciplinary team. Like, there are folks who are in like commercial ag. We have ag economists. Um, we have agronomists. We have me. I'm a biogeochemist. Very big word to swallow, but I'm mostly into nutrient cycles. We have entomologists who look at the pest side of things, and then we have plant pathologists who look at like plant disease, and then like disease resistance as well. And so, um, you know, we have like a multifaceted team. And so if there's anything that, flooding is doing, to your operation, like we want to hear about it because it's also probably something that we may not be looking at that's important.
Exactly. And I guess to throw another one in there that we would be interested in is, what is going on with your drainage system under there? Is that something that, again, do you have any tile out there? Is it surface intakes? What are some of those management practices that you have in your field, or what could be done in the future too?
Yeah, and we're doing that with remote sensing. We're actually looking to see like, okay, did this person repair their tiles recently and comparing that to before when there was an inundation event. And I think like those visuals on what's working actually is really good incentive for farmers to update, maintain tiles or even look into installing something it not saying that it's not sophisticated already, but something more sophisticated or like more custom or for different areas of their field.
Awesome. Well, Christy, thank you very much for joining us here today. It's been a pleasure, and thanks for coming on.
Thank you for having me. I had a blast.